Welcome. In this little tutorial, I'm going to show you how to build a language in MPS. We'll build a little state machine language with events, variables, states, transitions, and guard conditions by reusing an existing expression language. We'll also build a second language that tests the original state machine language, and we can even run this to execute the tests. Finally, we conclude by illustrating how to build tabular notations and diagrams as part of the overall state machine story.
Alright, so here is the second part of the generator tutorial. This time we are going to generate a test case. In our test language, I have already created a new root mapping rule for the test case, and it generates a Java class. I use another property macro to use the name of the test case as the name of the class, and I've already added the extends clause where this one is test case from JUnit in order for it to play nicely with JUnit. The name of the test case is computed, right? So there is the test case does implement iname concept, but the editor doesn't let you edit the name, right? It only shows the name of the tested state machine, test subject. And the reason why this has a name anyway is that there is an implementation of a getter for the name property of the test case, which takes the name of the machine, the tested state machine, prepended with test underscore. And so it's this name we use here. So we can do a preview generated test, right? And a preview generated text. And what is the problem? Well, I should probably make the language first. Better. So here is our class test traffic light extends test case, and it automatically imports JUnit framework test case because the fact that I use this class here kind of prompts the import. Again, this is not text, right? That's an actual reference to that particular class that has been imported as a stub model into MPS because it's basically kind of part of MPS. It's even available automatically. You don't have to do anything manually. Now, the first thing we need to do is we have to have the subject, right? The thing we want to test. So we're going to create a member that holds an instance of the state machine we're testing, or more specifically, that holds an instance of the class that has been generated from the state machine we're testing. So, right, I write object machine equals new object. Now, this is again one of these half correct and half not so correct things, but point is I do want to generate a member. It should be called machine, and I want to type it to some Java class, right? So this is a classifier type, and so it means that you basically instantiate a class, but of course we want to instantiate the class that was generated from the test case. So reference macro, and that reference macro changes the reference classifier, right? So a classifier type, which is what this is, it points to the class classifier which it is a type of, okay? So that means we need to point to the class generated from the state machine, right? Node.machine is the reference in our test case that points to the machine we're testing, and so we use another name-based reference to resolve this. I might have to do something with packages. I'm not 100% sure. We'll see. And we do the same thing here. Here we do a class creator, and we use basically the same approach to find the class creator based on the name. So let's see if we do another preview generated text, whether it's able to resolve this, and it does, right? Private traffic light. It's in the package playground.example, which is derived from this folder structure, and our traffic light is in the same package, which is why this finally works. Right, all right, so that was the first part. We basically created a Java class that inherits from test case and that instantiates an object of the state machine, of the class generated from the state machine, which we want to test. So let's add a public static void main method to run this thing. And the way you run a test case from a main method, the way this works is simply by doing a JUnit core.main, right? And then you have to pass the name of the class you want to run. And so I'm just grabbing some class, for example, the one here, this class, right? Dot class dot get name, and then I need to resolve that reference to, again, the class that's generated from the test case. It might work automatically because it's used inside. So let's see if that actually works. Otherwise, we need to do a reference macro preview, and it does, right? So it takes the class which we have kind of used here, gets the class, gets the name. So basically that's a way of getting the class name, the qualified class name of the class that we just generated. So the main method kind of instantiates kind of itself in the JUnit framework. So that's good. Now the only thing that's missing is the actual test method. And the way you do test methods in JUnit is that you give it some kind of name, right? And then you attach an annotation, and the annotation you attach is add test. That's an annotation from JUnit. And now here is basically the actual content. So remember, the test case basically either asserts a state in the machine or triggers the machine with an event. If you remember the generated Java code, we have a method getCurrentState that gives us the current state, and we have a method trigger that we can use to send in an event, where events and states are represented as these publicly available static constants. So we have all we need, right? So how do we build this generator? Well, basically I'm going to use the following thing. I'm going to use system.error.println hello, println hello. Now, obviously, that's not a test implementation. So what I'm going to do next is I'm going to attach another macro here, and I'm attaching not a loop, but a copy source list. And it uses the contents of our test case here in the iterator. So what does this do? It takes the contents of our test case, literally these three things, and injects them here. It copies these nodes into this one. It thereby removes the system error println. So I wrote the println only to have some kind of statement to which I can attach this copy source macro, because I have to attach it to something, right? I could have instead also, I could have written whatever, new object, semicolon, or whatever. It doesn't matter. It's dummy code that goes away. I mean, when the state machine, when the generator runs, this is first physically copied in, and then the copy source ls executed, which means that the thing that was just copied in is kind of thrown away again and replaced by the inputs. Now, there is basically then an intermediate state where we have a Java method here, which contains these instances of concepts from our DSL. That's an invalid model structure. So we need to do, as our next step, tell MPS, the generator, what to do with these kind of invalid things that were just added. And what we do is we create a reduction rule. A reduction rule is basically something that is automatically triggered to kind of further reduce, meaning transform, stuff that has been copied in by these copy source L macros. So long story short, for the assert state thing, we want to replace this with a call on the get current state method of the state machine we're testing. So let me write this piece of code and I'll explain what it does afterwards, because it is a bit of a chicken and egg problem. So I'm going to create a class dummy with a method dummy, And here I want to call, you know, a method. So I'm just, another method. And I want to call that because the assert state should call a method. And so I can do that, right? I can actually do this differently. I'm going to create a field of type dummy, lowercase dummy. Okay, now everything is called dummy. That's not so helpful. Call this context. So anyway, I want to do a dummy dot another method. So this is a method call. Okay, so what is the method I want to call? Well, I want to call the getCurrentState method on my state machine, because this, of course, is a kind of representative of my of this field. Okay, so and then I want to basically do some kind of JUnit assert. So there is this test case dot assert equals, where I'm basically checking if the current state of my state machine is somehow the one I'm interested in. So let's dummy that as well. Field, public final int state. Final isn't important here, and I refer to dummy dot. Okay, I should have made it static. State. So somehow what I wrote here is kind of what I want to generate. I want to generate a test case dot assert equals. I want to call a method on some object. It's the getCurrentState method on the machine object, and then I want to compare it to a constant that I get from some public static member of a class. So first thing is, this at the template fragment is what I want to actually generate. The rest, I only need that so I can write this code. Remember, this is not text, this is valid Java code. So in order for me to be able to call a method on something, well, I need the something and the method, right? So I have to write it here. In order to access a static field of a class, I need to actually write a static field reference with a class on a field reference. So this is dummy code. And now I need to again use reference macros to connect it to the stuff generated in the here. I want to generate to that machine, and then I want to call the machine's getCurrentState method. So how do I do that? Well, I change this one reference macro, and I just write machine. So it tries to find a field in that current class called machine, and as it happens, there is one that has been generated before. And yes, it would be a good idea not to code these strings directly here, but to have a helper method which returns these names from one single place, so I have no opportunity of typos. But that's not so critical for my point here now. So now what's the method I want to call? Okay, the method I want to call is reference. It's getCurrentState. Okay, and then what do I want to compare it against? Well, that class here is again the class that was generated from the state machine. So it's like this here, right? Node machine.name. Oops, sorry. Oops. So how do I find the name of that class? Well, we are currently in an assert state, right? So we can go up the tree until we find the test case. We can ask the test case for the machine, and we ask it for its name, right? And so that is the name of the generated class as well. And then finally, that state variable needs to be referred to as the name of the state to uppercase. So let's see if this works, and then I'll go back and explain it kind of once again, the big picture. Oh, and by the way, we also need to somehow reduce the trigger thing so that it doesn't remain in an invalid state. So let's basically just reduce it to, for now, an inline template system. Sorry. Actually, let me do an inline template with context and just copy this thing here, right? Delete all the other stuff. Okay, and just system.error.print line triggering, right? And just use this. So it's not the final one, but it's now reduced to something as opposed to remaining an invalid structure. So let's see, preview. So this looks good, right? Almost. There's something wrong here. So we generate the test case, assert equals, machine is that reference, get current state is that method on the traffic light class, and then traffic light dot it couldn't resolve the reference. So, and the reason for that is why? Because somehow I forgot the two uppercase. Yeah, right. Sorry, the two uppercase was in the video I recorded with you guys, but in the kind of commit that I checked out to have a stable base, that wasn't there. So sorry for the confusion. I'm not gonna re-record the whole video because of this. I'm just gonna remove the dot uppercase and then things should be fine. So preview generated text, and now it works, right? And here is our stupid triggering that doesn't do anything yet. Okay, so let's revisit this. Actually, we can revisit it by building the same logic for the triggering, because it's the same structure. So what do we have to do? Well, we want to call a method on an object, right? So to be able, I can't write object.trigger because there is no object, right? So what I need to do is I need to somehow create an object on which I can call a method, right? Okay. And I don't have to use dummy. I can use literally Java object. So then I can do dummy, right? That's this guy here. Dot, and now I can call methods on object. For example, I don't know, let's use equals, because equals is a method that takes one argument, and what we want to generate is machine.trigger and then pass in the event, right? Because if you look at the generator for our state machine, there is this method trigger which takes one argument. Okay, so that's good. So this is what we want to generate. So that's the template fragment. The rest is scaffolding, which I need so I have a context against which to write the example code. This needs to be re-resolved to the machine, as we've seen before, machine. And this should be a method called trigger, right? And again, putting these names into helper methods makes it more robust. And instead of passing in 12, we want to, again, pass one of these references to a static field. So I'm putting this thing here. Now of course it's an event, but it's just a name, right? So I re-resolve this to the field that has the name of the event which we're triggering, and that is from our current node, which is it's the trigger machine thing. We get the event and the name. All right. And it's probably wrong, you'll see in a moment, but I'll leave it for illustrative purposes, right? So this didn't work. The triggering didn't work. Why? Because I told it to resolve this against a local in the same object, right? So we need to make an explicit class-based, that's the wrong one. Let's call it dummy2. So we can resolve this dummy2 dot event, and now we resolve this one, exactly like here, against the machine. and that one was correct. It was node.event.name. So if you will, the drawback of the fact that this is an actual model and not just text is that sometimes you need this scaffolding, which is really confusing in the beginning. We could have made this a little bit more simple by writing an abstract class somewhere that has all these things and then having our dummy code implement the abstract class, thereby kind of inheriting the context, but we don't necessarily have to do this. The nice thing about this is that, this is almost self-documenting. The object that represents the state machine, right? And then, this already or almost reads kind of, because it has all the context, it reads kind of nicely. All right, so let's see if that works. Preview generated text. Right, this looks better now. We can actually try to rebuild, meaning actually generate Java and compile it, which also worked. And now we can go to this thing here. In the code you can check out there is a little tail run test.sh, which then runs our generated class. And so if I do a run test.sh, it runs JUnit and does that successfully. So just to demonstrate that, if I go, close everything here, and go to here, and for example, change this to red, thereby breaking the test, Command F9 regenerates, going back here, running again, and the test fails. Making that green again, compile F9, running, everything succeeds. So we finally generated a Java version of the state machine and of the test, and executed it successfully, making it executable. That concludes the Java generator tutorial. In the next one, we're going to look at expressions and interpreters.